Welcome to the Explainer, everyone. Today, we are going on an archaeological dig. That's right, we are uncovering the hidden clues buried deep inside your Cambridge Computer Science and Information Technology exam questions. We're specifically targeting the Cambridge Information Technology 9626 syllabus, zooming in on one of the most notoriously tricky areas, topic 15.3, critical path calculations. If you've ever stared at a massive network diagram on a past paper and felt your brain just completely freeze up, you are exactly where you need to be. We're going to act like examiners today, digging into the core strategy. Layer by layer, we are going to reveal the perfect answer. I'm going to introduce you to two archetypical students you might recognize. First, there's Alex. Alex is the kind of student who overloads every answer with raw facts about nodes and durations, but totally forgets the analysis. Then we have Sam. Sam rushes through the paper, panics at the sight of a dummy activity, and completely misses the specific command word requirements. We're going to look at their flawed answers, grab our virtual red pens, and fix them together.
So let's start with the big question. Why do smart students like Alex and Sam consistently lose really easy marks here? Well, looking at the examiner reports, the source material reveals it isn't because the underlying math is impossible. I mean, it's mostly addition and subtraction, right? No, the real trap is that candidates struggle to apply these conceptual frameworks to completely unfamiliar contexts. They memorize one specific textbook example, maybe building a house or developing a simple app. But when the exam throws a total curveball scenario at them, like setting up a global cloud infrastructure network, everything just falls apart. Sam looks at the new scenario, rushes the forward pass calculation, and completely ignores the command word asking to discuss the impact of a delay. The context matters.
And this brings us to a massive revelation, which is what we call the method mark strategy. The secret is that examiners are actively looking to reward your systematic processing. They don't just care about the final number at the bottom of the page. Think about Alex. Alex might actually calculate the wrong total project duration because of a silly arithmetic error on task C. But if Alex clearly shows the layer-by-layer process, calculating the earliest start times, the latest finish times, and isolating the float, the examiner will still award the majority of the marks. The process is literally just as important as the destination in computer science papers.
Okay, let's take a quick look at our roadmap for this explainer. First, we'll be demystifying the critical path. Second, mastering core principles. Third, we'll break down the technical methodology. Fourth, we'll uncover the top 3 examiner warnings. And finally, we'll wrap up with the evaluative mastery strategy.
All right, let's jump straight into section 1, demystifying the critical path.
Let's be real for a second. Rote memorization simply won't cut it anymore. True mastery in Cambridge exams equals a connected, conceptual understanding that is highly transferable. To get there, top students don't just dump facts. They use frameworks, specifically the Peel framework: point, evidence, explanation, and link. If a question asks you to analyze a critical path, your point states the core issue. Your evidence is the specific task duration or float from the diagram. Your explanation details how a delay shifts the latest finish time, and your link connects it right back to the overall project impact. This structure forces you to build that conceptual understanding the examiners are literally begging for. Moving on to section 2, mastering core principles. You have to understand that the examiners are actively hunting for 3 specific assessment objectives or cognitive domains in your answers. First up is pure knowledge and understanding. Do you know what a dummy activity actually is? Second is application. Can you take that knowledge and map it onto the weird, unfamiliar scenario they've given you? And third is analysis. Can you dissect the data and figure out the cascading effects or a network failure? Balancing these 3 domains is how you get the A star. Now, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, jumping back in. If you're like Alex, you might be great at the knowledge part, but if you don't apply it to the scenario, you're leaving massive points on the table.
Here is a hidden gem straight from the principal examiner reports, and it's a huge part of what we call the computer science success blueprint. Candidates who make cross-topic connections score significantly higher. Don't view 15.3 critical path calculations in a vacuum. The examiners love it when you connect project management concepts to other syllabus areas. How does an expanded critical path affect hardware procurement timelines? How does it tie into the software development lifecycle? Making those connections proves a much deeper level of comprehension. It shows you're not just a student, you're thinking like a systems architect.
This brings us to section 3, the technical methodology. This is where we start transforming those broken answers.
To guarantee success, you need a repeatable system. Look at this 5-step sequence. First, deconstruct the command words. Is it asking you to state, calculate, or evaluate? Sam lost marks by treating an evaluate question like a state question. Big mistake. Second, extract the relevant data layer by layer. Third, select your analytical framework, like the Peel method we talked about. Fourth, execute with crystal clear notation. Show your forward and backward passes clearly. And fifth, present your final findings using the exact correct terminology. If you apply this success blueprint, you're going to see your answers transform from heavily red penned to completely green checked.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2-3 grade boundaries. Join them right now by subscribing to acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. Okay, let's put this into practice with a mini interactive workshop right now. Challenge 1, the data scan. Imagine a complex data table mapping out network installation tasks. You have exactly 60 seconds on the clock in an exam to find the core dependency trend. Execution is everything here. You have to interpret the relationships between predecessor and successor tasks quickly. You're basically acting as a data detective, drawing out evidence-based conclusions before you even start drawing your node network.
Let's head into Section 4, the top 3 examiner warnings.
Time for Challenge 2 in our interactive workshop, Find the Flaw. I want you to imagine Sam wrote this paragraph. The critical path is the longest part of the project. If it is delayed, the project is delayed. What's the flaw? The failure point here is that it's an incredibly vague generalization. The examiner knows what a critical path is. What they want to see is you applying that to the specific scenario. A top-tier answer would be, because task D, server installation, is on the critical path with 0 float, a 2-day delay here will directly push the entire database migration project from 40 to 42 days. See the difference? Specific details win every single time.
So, engrave these 3 warnings into your brain. 1, vagueness is your enemy. 2, poor format and presentation will obscure your method marks. And 3, failing to reference the specific context of the prompt is a total disaster. Let's do Challenge 3, speed writing. You have 30 seconds to mentally outline a perfect Peel paragraph right now that avoids all 3 of these pitfalls. Point, state the dependency. Evidence, quote the duration from the table. Explanation, show the math. Link, connect it to the final project deadline. This is how you outsmart the exam paper.
Finally, let's unlock Section 5, Evaluative Mastery Strategy.
Before we hit the highest tier of answering, we have to clear up a massive red flag that ruins otherwise great papers: terminology. Candidates consistently confuse key terminology. They mix up free float with total float, or they misuse the term dummy node. Never just assume the grader knows what you mean, and never use a technical term casually. A great strategy is to define your terms immediately in your extended responses. This locks in those knowledge marks right out of the gate, setting a professional tone for the rest of your answer. Now let's look at the ultimate answering system. Notice how the hierarchy of marks builds up. At the bottom, you have the descriptive level, just stating facts. Alex gets stuck here. In the middle is the analytical level, where you explore causal relationships. But to reach that coveted evaluative level, you have to upgrade your approach completely. You need to decode the command words, apply the Peel framework flawlessly, and use a time management matrix to ensure you leave enough time to actually justify your recommendations. You have to evaluate alternatives. If the project is delayed, do we add resources to task B or task C? Why? Give me the evidence.
Here is a huge tip for hitting that evaluative level: comparative analysis. When a question asks you to compare 2 different project management approaches or network paths, do not fall into the trap of only listing similarities. You absolutely must identify similarities and differences. Moreover, you need to use comparative connectives. I'm talking about words like whereas, conversely, or in contrast. Using these transition words actively forces you to weigh the evidence and draw sharp, high-level conclusions about relative importance. This quote right here perfectly summarizes what the examiners truly desire. They don't just want a human calculator. They want to see you thinking critically, like a seasoned professional. They want to see you questioning the assumptions provided in the scenario. Consider different perspectives. What happens from the client's point of view versus the developer's point of view if a critical node is delayed? Justify every single decision with hard, undeniable evidence pulled directly from your calculations.
Ultimately, the overarching goal of mastering Topic 15.3 isn't just about passing a Cambridge exam. It's about proving you have the practical professional skills to manage real-world IT projects. Applying correct formats, using the right terminology, and thoroughly evaluating performance are skills that translate directly into the tech industry. Now, listen closely. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
So we arrive at the final question. When you sit down in that exam hall, will you rely on fragile memorization like Alex and Sam used to? Or will you apply the examiner's playbook? Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to at acetheexams_IGCS and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.